This PowerPoint presentation looks to the week ahead. This week you will practice some of the theoretical concepts in biostatistics by exploring variables from a longitudinal study. We will focus on statistical tests to compare mean values and statistical comparisons of prevalences between groups. In order to test means and prevalences, your assignment this week will be to explore a limited set of variables from a publicly available data set that is posted on Blackboard. The data comes from the National Longitudinal Study of Adolescent to Adult Health, ADHealth. The data is longitudinal with exposure variables that were measured in adolescents in 1996 in relation to outcomes that were measured in 2008. In this PowerPoint, I will show you how to explore continuous variables. You might decide to explore categorical values, but it is important to know how to explore a continuous variable, so this lecture will guide you through the process. You have already done explorations to get mean and median values in epidemiology. Here you will learn how to get a statistical analysis or a p-value of the comparison. Most of the continuous variables have been categorized using clinical cutoffs. For example, blood pressure is given as systolic and diastolic as continuous variables, but the results have already been converted into clinically meaningful categories. You will need to make a choice about which outcome variable you will use. Your options are limited to the topics included in the variables data table. A cluster of variables related to healthcare access are also included, although none of them measure access directly. For example, one variable is a question about whether or not the respondent had health insurance in the Wave 4 survey. Another option is the number of months out of the past 12 the respondent had health insurance in the year prior to the survey. In this exploration, choose one variable you are interested in to explore in relation to 2 to 3 exposure variables. If the outcome is continuous, you can compare the mean values of the variable at different levels of the exposure. Before running the comparison, explore both variables to be sure that the mean comparisons are appropriate. Namely, don't forget to test that all numerical values identifying missing information are not included in the means. If your outcome is dichotomous or categorical, try to combine groups to have no more than 4 categories for the chi-square comparisons. If you can't, just expand your table, but it will be more time-consuming and harder to explore results if you have several categories for both your outcome and your exposure. While it might be tempting to explore multiple versions of the same outcome, it is important to choose just one. This will save you time and allow you to explore each of the variables more carefully. So select the one variable that best reflects the outcome you are interested in. In your initial explorations, you can include all of the variables, outcomes as well as exposures, in your initial explorations. The best starting point is to explore the variables of interest using the function you are already familiar with from epidemiology. Namely, click on Analyze and then Descriptive Statistics and Frequencies. Under Frequencies, you can explore continuous as well as categorical variables. If you have a continuous variable in your list, select minimum, maximum, mean, and median. These values will only be meaningful for the continuous variables, so consider that when reading your output. If the variable is categorical, consider limiting the options to just 3 to 4 groups to facilitate further explorations. In your explorations, you may find that variables are given values that are not meaningful, such as a 99 or 999, that is used to indicate missing information. You can set these to missing by going into the variable view of the data set, going to the missing column, and then clicking on that cell. When you click on the cell, the option to enter missing values will pop up, as you see here. You can enter these as discrete values, as in this example, or you can click on a range to give, for example, the range from 96 to 98. After entering any numbers as missing, be sure to save your data set and double check that the change worked by exploring the variable again. You can check this under frequencies. The numbers you have set to missing should show up in the table as missing values. Double check the mean and median from your initial exploration to see if it changed after setting values to missing, and don't forget to include any changes you make, for example, any additional explorations, to your syntax and output file. Based on the results, consider collapsing your exposure variable to just 2 to 4 categories. Most of the exposures are already limited to 4 categories, but if there are more categories, it may be hard to make anything of the results. In that case, combine groups that can logically be clustered together. The next step after exploring the variable separately is to explore the outcome in relation to the exposure variables. The statistical comparison you will use will depend on the type of outcome you have selected. If the variable is continuous, you can use the t-test for statistical comparisons. The t-test can only compare between 2 groups, so if you have multiple levels of the exposure, you will need to test them one at a time. Here are the instructions to do a t-test comparison. Use the independent samples t-test because your exposure categories are mutually exclusive. If you had a data set where the same person could appear in multiple exposure groups, the independent t-test wouldn't work. And this is what it looks like to select the continuous variable. In this case, I'm using the example of BMI, and to compare by categories of activity level. The grouping level gives the contrast. Here it is level 0, no activity, compared to 3, the highest level of activity. Because there are 4 groups, you will have to do this process 3 different times for 4 exposure levels. For this reason, try to limit your number of exposure groups. This shows the steps you will need to take, so you would need to do each of these t-tests one at a time to compare all of the means with 4 exposure levels. This slide shows the output of the t-test from SPSS. The first result shows the sample sizes, mean, and standard deviation. You can check the standard deviation to see if the standard deviation is the same for both groups. The significance, two-sided, shows the p-value of the mean difference. Next, we shift to the chi-square comparison. This is a function that you have also used previously, namely under the crosstabs function. I will use this example with the exposure entered under rows and the outcome as columns. It doesn't actually matter which you choose for rows and columns, but to match the sample table that I gave, and to make it easier to integrate multiple exposure results into one table, it is easier if you set up the exposures as rows. Again, this is already familiar to you. The difference from what you did in epidemiology will be in the selections you make under cells and statistics. Here, I'm showing the option where you click on all possible options that are of interest. Here I select expected values because this shows what the number of individuals would have been if there were no differences across groups. I recommend selecting hiding small counts, or when you see the result, looking specifically for the cells that have less than 5. The selection of rows and column percentages depends on whether you want to know the percent of individuals exposed by the different outcome categories or vice versa. It is usually good to see them both first and then make another selection when you create your final table. So when it comes to the selections, note that the observed value is simply the actual data. The expected is how many people would have been in that group if the groups were not different, and you should ignore any results if the sample size or the cell size is less than 5. This is what the table looks like comparing the exposure categories, active sport, compared to the outcome BMI class. Next, I'm going to do the same process again to get the results that I can easily put into a descriptive table. So I have removed the additional information. I'm clicking only on Observe to get the sample size, or the N, and the row percent so I can get the percentage of the BMI categories for each of the activity levels. There is also an option for charts to get a visual of this data, but for this assignment I need the percentage of the outcome BMI categories across all exposures and for all categories of the exposures. So it is easier to get that in a table where you can add rows to reflect different exposures and different levels of exposure. Here you can see that only a very small percentage of are in the BMI class 1 category, which is underweight. You have more in the level 2, so you have 31.9, 32.4, 30, and 30.6% of the population in the normal weight category, and a large majority of the population is in the overweight, obesity 1, 2, and 3 level categories. So this table helps me make decisions about where to keep my cutoffs. If I'm interested in keeping multiple groups, I would combine the underweight and the normal weight together. I would leave the overweight as its own category or combine it with obesity class 1, and then I might consider putting the groups 5 and 6 together to see what those results look like. Never give SPSS output in a paper, for a report, or in a PowerPoint presentation, but if you set up your SPSS output well, it will be easier to create a table from those numbers. Here's an illustration of what it would look like. As you can see, there are too many BMI classes to create a reasonable table. For this reason, it is a very good idea to recode your outcome into 4 or less options. But even without recoding, the chi-square results show that adolescent activity is significantly associated with adult BMI categories. In looking at the p-values, which are in the right column under the title Asymptotic Significance, the results are the same conclusion. For now, it is only important to explore the prevalences across categories and to see where to look for significance. We can talk more in depth about the different assumptions of the chi-square test when we get to Chapter 6, which covers the 2 by K contingency table. Here you are using longitudinal data, but you don't yet have the information you need to calculate a risk ratio. We have an exposure measured 20 years before the outcome, but to get a true risk ratio, we would need to know how many developed the condition, in this case BMI greater than 25, and the exposed versus non-exposed. What is the risk of overweight obesity in students who were inactive compared to those who were active? This is the conclusion of the PowerPoint presentation related to your assignment this week. I look forward to seeing you in the tutorial sessions and in individual meetings this week. Thank you.